Okay, today we are starting our study of matrices, and hopefully you remember that a matrix is just a rectangular array of numbers, but we have operations and things we need to know about matrices before we can move on. But one of the things that they are useful for is organizing data. So what we're going to do is take some information here. It is the population. Table displays U.S. Census data, Latino population in the U.S. in millions. And we're going to organize that data into a matrix. Okay, so the values that change, or similar to what's at the top of your page as an example. So in part A here, we have a group that goes from 0 to 19, from 20 to 39, from 40 to 59, and then 60 and older. Okay, so our matrix is going to be, we are going to have 7, and actually we're going to do it just like it is in the chart here. So our first column will be male, and our second column will be female. So basically 7.1, 6.6, 6.8, 5.9, 3.2, 2.2, 1.1, and 1.4. Okay, one of the things that I do need to make sure you know is, or to remind you, that these matrix, the dimensions of a matrix are always rows by columns. So the dimensions of this matrix would be, it's a 4 by, actually I don't want to write that there because I got to write something else there. So let me erase that. This matrix is a 4 by 2 matrix. You always do rows first and then columns. And I remember that because I know there's a drink called RC Cola, so it helps me remember that R comes before C. So you have 4 rows and then you have 2 columns. Okay, so moving on to the second part. B says add the elements in the columns and interpret the results. So part B, if I add this column, I'm going to get 18.2. And if I add that column, I'm going to get 16.1. Interpret the results. So what that tells me is that 18.2 million Hispanics are males, and 16.1 million Hispanics are females. Okay. Part C. Part C says add the elements in the rows and interpret the results. So if I add my rows, here I'm going to get 13.7. Here I'm going to get 12.7, 5.4, and 2.5. And I have to interpret those results. So basically we have that 13.7 Hispanics are between ages 0 to 19. Then we have 12.7 Hispanics. I'm going to go ahead, I'm sure y'all don't mind, make it go faster, are between the ages of 20 and 39. We have 5.4 Hispanics are between the ages of 40 to 59. And then, of course, 2.5 Hispanics are between the ages of, actually are between the ages, basically 60 and older. Okay? Would finding the average of the rows or the columns provide any meaningful data? I think we can all agree that the answer to that would be no. Needs to quit flashing at me. Okay? So that's just analyzing the data that's in a matrix and understanding, what it represents. Okay? So the next thing we need to talk about are some operations with matrices. Matrices can be added or subtracted if and only if they have the same dimensions. So the dimensions are what I just talked about in the beginning there. It's supposed to be this. Dimensions, and that is, excuse me, your rows and your columns. Those are the dimensions of your matrix. Okay? Once you have those dimensions that are the same, then basically corresponding elements are then combined. Okay? So as it says, and to start off with, adding and subtracting. To add or subtract two matrices with the same dimensions, add or subtract, again, their corresponding elements. Okay, so I don't know if I have enough colors. Let's see. So the corresponding elements here, let's see, how many do I have on my, I have four, so that'll work. So we have A and E are corresponding elements. So to get the one, when we add them, we're going to add A plus E. Then we have B and F are corresponding. That gives us that place. We have C and G that correspond to give us C plus G. And then we have D and H, which give us D plus H. The other thing I want you to remember or make sure that you know is in a matrix, um, keep in mind it's written like this. A11 means the first row and the first column, the element that's in the first row and the first column. So this one right here would be first row, second column. This one would be the second row, first column, and this would be second row, second column. So you do need to be familiar with that notation. Let me go ahead and highlight that also so you can see how they go together. So that's that one, and then we have that one, and that one, and that one. But that's how it's named, and there's an example for you to look at. Make sure that you understand. So let's do a few of those, then we'll talk about scalar and be done. Oh, there we go. So add or subtract the matrix in A, so 2A. We're just going to add those corresponding elements. So keep in mind this is a 2 by 2 and a 2 by 2. Our result will be the same dimension of a 2 by 2. So negative 3 minus a negative 4 is 1. Negative 3, excuse me, 4 minus 12 is negative 8. Negative 9 minus 8 is negative 17. And negative 5 minus a negative 7 is 2. So that's the answer that we have. Look at B, 2B, or not to be. Again, this is 2 rows, 3 columns, 2 rows, 3 columns. So negative 9, actually go ahead and put my matrix form up there. Negative 9 plus negative 4 is negative 13. 8 plus negative 3 is 5. 3 plus 6 is 9. Then I move to my second row. Negative 2 plus negative 9, 4 plus negative 5, and negative 7 plus 18. So there you have it. And the last one, 2C, this is 3 rows, 2 columns, and this is 2 rows, 4 columns. They're not the same dimension, so if you are asked to add them or subtract them in this case, you would write that it's not possible. Okay, last thing we got to talk about is a scalar. Multiplying by a scalar. A scalar is just a number on a matrix. A matrix, remembers that rectangular array. And just like you have the distributive property, you've got to remember that that k is multiplied by every element, each element in your matrix. Okay? So, for example, multiply t, or find negative 4 times t. So I have to go multiply each element in here by negative 4. So I'm going to have negative 32, 0, negative 12, 8, and, oops, I didn't mean to do that. And then, of course, 4, 16, 8, and negative 36. Okay, the last thing to make you aware, you can find it out the long way by doing it, but I just want to reinforce it with you. So we'll talk about these real quick. Properties. Commutative property of addition for matrices holds true. So a matrix A plus matrix B will equal matrix B plus matrix A. The associative property holds true. A plus B plus C is equal to A plus B plus C. The left scalar distributive property, okay, and this is important as we're going to get into multiplication next time, okay, that is Ka plus Kb, and the right one is going to equal O times K is going to still equal Ka, so it does not matter. Okay, we will talk about more specific multiplication or multiplication of matrices next time, and it is very different. So if you have any questions, email me, and I will see you soon.